So this video is on exponential functions. General equation is y is equal to a, which is a stretch, but you can also think of it as the initial value, the starting value. Y-intercept, if the graph is not translated up, down, left, or right. The b is your base or your multipliers, which you're timesing by to a power. X minus H, this is your left-right movement, and then the plus K is your up-down movement. Now, you will have a locator point that's going to help you figure out where your initial value is and your asymptote, your horizontal asymptote. So again, it's going to be like all the other ones we've seen. It's going to be H comma K. Now, your horizontal asymptote is going to be Y is equal to K. So I am going to first be graphing y is equal to 2 to the power x. Now, a little note here. Any number to the power 0 equals 1, with the exception of 0 to the 0, which is undefined. So what that means is if I have just a base to a power, my a is really just a 1. Doesn't matter if it's 2 to the power 0, 3 to the power 0, 1/4 to the power 0. Any number to the power 0 is going to be 1. So the y-intercept, if the graph is not moved and you do not have a stretch, is always going to be at 0, 1. Okay. And as long as you don't have a plus or minus k here, your asymptote is going to be at y equals 0. So what I'm going to be doing is I'm going to be just plotting 2 to powers. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, because my x's, which are in my exponent, that is what my values that I'm going to be putting in. So I'm going to be putting in the exponent to raise 2 to a power. So let me just get some points here. Okay, so let's say I'm going to graph this in purple. And let me just zoom a little bit more. So if I go to 0, 2 to the power 0 is 1. So I have a point at 0, 1. When I go over 1, 2 to the power 1 is 2. When I go over 2, 2 to the power 2 is 4. So I'm going to go to 2, 4. When I go out 3, 2 to the power 3, because I'm raising 2 to these powers on the x-axis, so 2 to the power 3 is 8. When I go 4, 2 to the power 4 is 16, so I'm going to go up to 16, and so forth. Now, if I'm going in the negative direction, when I raise 2 to a negative power, it's going to be the reciprocal of 2 to that positive power. So if I take 2 to the negative 1, 2 to the first is 2, 2 to the negative 1 is the reciprocal 2, which is 1/2. When I go out 2, 2 squared would have been 4. 2 to the negative 4 is going to be 1/4. Okay, right now I have my dots a little too big to represent that. 2 to the negative 3, well, since 2 to the third is 8, 2 to the negative 3 is the reciprocal of 8, which is 1/8. Now, for this graph, we are going to have an asymptote because it's going to get closer and closer and closer to 0, but it's never going to cross. So let me draw in this asymptote. Actually, I was going to do it in a different color. Okay, so I'm going to draw on this asymptote. It is a horizontal asymptote. The equation of this horizontal asymptote is going to be y equals 0. Now, I'm going to connect these points here in a second, but just to kind of think about what's happening here. So remember, anytime I raise any number to the power 0, I get a 1. So as long as I'm not moving this graph left or right or up or down, or that I have an a in front, which would affect my y-intercept or my starting location, my starting value. anytime I'm taking 2 to the power 0, I'm going to be at 1. Okay, so that's going to be my first height, unless I have an A. Then I would go A away. Now, what's happening here is this is 1 high. Now it's 2 high. Let me just write these numbers down. So I am 1 above the asymptote, 2 above the asymptote, 4 above the asymptote, 8 above the asymptote, 16. The next one would be 32. I am taking 2 to powers, but what that means is I am doubling, I'm timesing by 2. So my first height is 1. I double that 2. I times that by 2, 4. I times that height by 2, 8, 16, 32, 64. Going backwards, 16, half of 16 is 8, half of 8 is 4, half of 2 is 1, half of 1 is a half, half of a half is a fourth, 1/8, and so on. Now, as I go half and half and half, I will never get to 0. I'll always have half of that left. Now, let me connect this and show you what our exponential curve is going to look like. So it's going to get purple here. Okay, so it's going to be getting closer and closer to that asymptote. This one is an exponential growth because it's increasing. I'm timesing by a number bigger than 1. So it is going to be making this an increasing graph. So I have Desmos open here. I have graphed y is equal to 2 to the power x. And you can see this is what the graph looks like. I have the table down here. You can see these values. Okay. So 2 to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8, and so forth. So you see that every time I am doubling the height before. And again, if your A is a 1, meaning that you don't have a stretch in front of here besides a 1, you just have a base to a power, then your y-intercept is going to be 0, 1, unless it's being shifted up or down or left or right. Now, just to show you what bases are acceptable and which bases are not acceptable, let's say I do a 0. Okay, let's say I do a 0. So if I do y is equal to 0, what you see happens here is I'm actually going to get a ray. Okay. And really here at 0, 0, this really should be an open circle. It's undefined because 0 to the power 0 is undefined. And 0 to a negative number is also going to be undefined, because if I take, for example, 0 to the negative first, what I'm really doing is 1 over the reciprocal. So 1 over 0, which is undefined. And when I'm doing any other 0 to a negative power, so let's say I'm doing 0, get a eraser here. Okay, try it one more time. So if I am having 0 to, let's say, the negative second, that is going to be 1 over 0 squared. Okay, it's going to be the reciprocal of 0 squared. And 0 squared is 0. So I'm going to end up with a 0 on bottom again, which is going to be undefined. So what's happening here is I have an open circle here at 0, 0, making it look like a closed circle, but it is an open circle here at 0, 0. And then I basically have a ray going. And that's not going to be exponential. So let's try a different base. So let's say I have a base of 1. So if I have 1 to the power x, you see that I just get a horizontal line. So that's going to be linear, not exponential. So far, 0 to the power x did not end up with an exponential situation. 1 to the power x did not end up with an exponential situation. If I do 2 or 3 or 4, any of those positive powers, I definitely know that that's going to work. Okay. So let's say I take a -2 and I raise that to a power. So when I take a -2 and raise it to the power and I have this on Desmos, you see it didn't graph anything. The reason it didn't graph anything is because I cannot have a base be negative. The reason is I'm going to come down here to this table and I am going to adjust this so that this is going to be the quantity -2, close my parenthesis, raised to the power x, and let me get those points. Now, what's happening is when I take a negative to an even power, I'm always going to get a positive. So you see I'm getting a positive value here because this is 2 to the 0, 2 to the second, 2 to the fourth. But when I do -2, I should say 2, -2 to those powers. When I do a -2 to an odd, so -2 to the first, -2 to the third, and so forth, I end up getting, let me see if I can zoom out a little bit. I end up getting negative numbers. Okay, so you see I end up getting negative numbers. Let me just get it back to normal. Now, I also have here 1/2. When I raise -2 to a 1/2, I am really square rooting. And the square root of a negative is going to be imaginary, and that's why it's undefined. So what's happening when I have a negative base, I am getting points that are above, below, above, below. So they're alternating between above the x-axis, below the x-axis, and I have gaps in between where I have something like raised to a 1/2, where a -2 to the 1/2 is going to be undefined because it's going to be imaginary. So again, I cannot have 0 to the power x because it's linear. I can't have 1 to the power x because it's linear. And then when I have 2 to the power -2 or any negative number to the power, it is also not going to be exponential. So if I, again, get rid of those points, you see you kind of got these points here and there, but it's not going to be a continuous graph. Okay, it's not going to be an exponential situation. So what that means um, is that I am going to have bases. Let me get my cursor here. I'm going to have bases that cannot be 0, cannot be 1, cannot be negative. So it has to be a positive number that's not a 0, not a 1, cannot be negatives. Okay. Now you also see I have two situations here. If my base, my b, is greater than 1, it's going to be exponential growth. If my base is less than 1, but between 0 and 1, a decimal fraction between 0 and 1, it's going to be an exponential decay. So let me bring back my Desmos for a second. Let me get rid of this one here. So here I have y is equal to 1/2 to the power x. Now, if I show that with this 2 to the power x, you see that it's symmetric. You see that it is a mirror image. So 2 to the first is 2, 1/2 to the -1 is 2, because negative exponents mean that you're taking the reciprocal of that base to the power. Okay. Now, I also have here y is equal to 2 to the -x, which is actually going to give me the same graph as this purple decay, because my red is y is equal to 2 to the power x. So all of these positive x values have these outputs, okay, these outputs. Now, when I make my x negative, that means that what I had for my +1 as an output, I'm going to have for a -1 as the output. What I had for a +2 as the output, I'm going to have for a -2 for the output. So when I do this 2 to the -x, you see that it is going to be the same graph. Let's see, it's hard to see. Okay, so here's 1/2 to the power x, 2 to the negative x is going to end up being the same graph, this one right here. You can see right there, see that black, purple, black, purple. So these are exactly the same. Now, the last one I want to show us is if I have a negative, not that I'm taking the negative of a number to a power, but I'm taking the positive base to a power and I have a negative outside. So my base is not negative. I'm raising my base to a power, then I'm making it opposite. So when I click this one, you're going to see that's going to flip that graph and over across the x-axis, and that's what that graph's going to look like. So let me come back to this. So over here, again, if my b is greater than 1, it is going to be exponential growth. If my b is between 0 and 1, a decimal fraction between 0 or 1 is going to be an exponential decay. Your base cannot be 0, it cannot be 1, it cannot be a negative. Now, if I was to take this same graph here, where my b is greater than 1, but now I am going to make it be a negative in front of that same b to the power x. It is just going to become a mirror image. It's going to flip it across the x-axis like this. Same situation over here. So again, if I have y equal negative b to the power x, negative b to the power x, where again, my base is between 0 and 1, it is going to be a mirror image of this decay. So it's going to be looking like this. Just going to flip it across the x-axis. Okay, so now let's try doing some graphs that have been transformed, okay? So first one, let's say we have y is equal to 3, okay? Our base is 3 to the power x plus 5 minus 9. So we are going to have an asymptote, okay? And we are going to have a locator point that's going to help us find that asymptote and also the start of our graph. So my locator point is going to be at -5 because that's what makes the x plus 5 0, the exponent 0, and then minus 9. Now, my asymptote is going to be a horizontal asymptote through that. So if I was to go to -5, -9, okay, so let me go to -5, -9. Let me zoom out a little bit. Okay, so -5, -9 down here. That is going to be my locator point. I am going to have an asymptote, a horizontal asymptote going through there. So it is going to be at a height of -9. I'm going to make this a dashed line. Okay. And that equation for that horizontal asymptote is going to be y equal -9. So that's what my asymptote, y equal -9, okay? And you can always find it right here because of that is what's moving your graph up or down. Now, that means that I'm going to start right here. Okay, I'm going to start right here. I'll do the graph in purple. So I'm going to start right at this point, and this is where I'm going to start 3 to the power 0. So 3 to the power 0 is 1, so I'm going to go 1 above. Now I can go out 1, and 3 to the 1 is going to be 1, 2, 3. From this locator point, I'm going to go out 1, 2. 3 squared is 9, so I'm going to go up 9, which means I'm here at 0. Now, what's really happening also is I'm always going to start at 1 above unless I have an A that's different than just plain old 1. And then this base is telling me what I'm multiplying by. So I'm multiplying by 3. So this is 1 away, times that by 3, 3 away, times that by 3, 9. Next one's going to be 27. So let's see. I'm going to go, so it's 9. So 27, I'm going to be up here at 18. That's going to be 27. And then I can connect my graph with my curve. There you go. Now, let's say we are going to try where we have a 1/2. So this time, this is going to be a decay. Every time I'm going to be half as high, half as high, half as high. So my locator point is going to be at 10, positive 10, comma 4. And my asymptote is going to be at y equal 4. So if I go to 10, comma 4, 10, comma 4, I'm going to start right here. That is where I'm going to have my asymptote, my horizontal asymptote. So at a height of 4. And we always give the equation of that line. So that is going to be y equal 4. And then I am going to come to this locator point right here, this locator point, and 1/2 to the power 0 is 1. 1/2 to the power of 1's a half, and then a fourth, and so forth. Okay, so I'm going half and half and half and half. Now going the other direction, what is happening is if I'm going half to the right, that means I'm doubling going backwards. So if I go to the left 1, it's really 1/2 to the negative 1, which is a 2. If I go out 2, it's really 1/2 to the negative 2, which is going to be a 4. 1, 2, 3, 4. But what you see is really happening is I'm going half and half and half as I go to the right, but as I go backwards to the left, I'm doubling. So if this is 4 above, my next one's going to be 8, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16. And that's going to be our graph. And you can see it's an exponential decay. Okay. Now let's try it with a stretch with an A. Oh, actually, let's just try with a negative in front first. Okay. So that negative is just going to flip it because that's not a negative 2 to a power. It's a negative and then 2 to a power. Okay. So my 2 is being raised to a power and then being times by a negative. So let's see, my locator point. That negative is not going to affect my locator point. So it is going to be 8, comma 16. 8, comma 16. And so 8, comma 16, and my asymptote is going to be y equals 16. So let's go to 8, comma 16. So 8, I'm going to kind of zoom in a little bit. Okay, so 8, 16. And that is where my asymptote is going to be. So I'm going to have a horizontal asymptote at y equals 16. And then because it's negative, when I go to this locator point here, I am going to be not starting one above, I'm going to be starting one below. And then because this is a 2, if this is 1 away from the asymptote, as I go over 1, I'm going to double that, 2 away. As I go again, now it's going to be double that, which is going to be 4 away. And then double that, 5, 6, 7, 8 away. Double that, 16, which actually is going to put me down here. And so forth. And when I connect this, this is the graph that we're going to get. Now, let's say we have an A. We'll do one where it is a growth, and then we'll do one where it's a decay. So let's start with this one here. So y is equal to 5 times 2 to the power x minus 3 minus 4. So our locator point is going to be at 3, comma, negative 4. My asymptote is going to be at y equal negative 4. So I am going to put a locator point at 3, negative 4, and then draw my asymptote through there. Okay, so 3, negative 4. So that's going to be right here. I'm going to draw my asymptote through there. Okay, so get my horizontal line. Try it one more time. Okay, my horizontal line through that. And label it. Y is equal to negative 4. And then where that locator point is, that's where I'm going to start my graph. Now, when I say start my graph, this A is how high above the asymptote you're going to be at that locator point. So I'm going to be starting 5 above. So I'm going to go 1, 2, 3, 4, 5 from that locator point, 5 above that. And then this 2 is saying that I'm timesing by 2, timesing by 2. So as I go to the right, I'm timesing by 2 every time I go over 1. So I'm 5 above. I'm going to double that. So now I'm going to be 10 above. So that's 5, 6, 7, 8, 9, 10. And then I'm going to go 1, 2, 3. And then I'm going to double 10. So I'm going to go 20. So that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, if I wanted to continue going the other direction, I'm doubling going to the right. But if I'm 20 above, 10 above, 5 above, I'm taking half going the other direction. And half of 5 is 2.5. So I'm going to go 2.5. Half of 2.5 is 1.25, and so forth. And let me connect that. And there's my graph. And then let's try one decay. So in this case, we have y is equal to 24 times 1/2 to the power x plus 7 minus 4. So my locator point is going to be at -7, -4. So, whoops, let me make that a little thinner. I had to change this. Okay, -7, -4. And then my asymptotes at y equal -4. Okay, so I'll put that point at -7, -4. It's going to be right there. I'm going to have my asymptote going through that, my horizontal asymptote. And then after I label this y equal -4, I am going to go to my locator point. Okay. And let me just make it, my locator point was here at -7, -4. So from there, I am now going to start 24 above that. So I'm 4 below, so that's 4. So I'm going to go up 20. So that's going to be 24 total. So I'm going to be all the way up here. So I'm going to start 20 high, 20 above, sorry, 24 high, 24 above my asymptote. And I'm taking half. So as I go to the right, I'm timesing by half. So half of 24 is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then half of 12 is 6. So 1, 2, 3, 4, 5, 6. Half of 6 is 3. 1, 2, 3. Half of 3 is 1.5, and so forth. And here is our exponential decay graph. So hopefully that helps you out with exponentials. Just remember that, let me just get all the way to the front. So just remember that our bases can not be 0, 1, or a negative. So it has to be a positive number, not a negative number, but it cannot be 0 or 1. If your base is greater than 1, it's going to be a growth. If your base is between 0 and 1, it's going to be a decay. And your locator point, your horizontal asymptote is going to go through that. And that locator point is going to tell you where your start is.